This is a quick getting started demonstration for setting up the extensible blockchain object model, the Xbom development environment for developing classes for the environment. The sources, the publicly available sources, which will be once with registration, are in our GitLab under the Prasaga.com HLFXBOM-public. And the sources are sitting in this tree. There's a handful, there's classes, and there's the core class manager infrastructure code in here, and environment, and the rest of the environment setup. The README file explains quickly how to set it up and some other information about it, and we're going to walk through this very quickly. So from the top, the Xbom environment has been run on Ubuntu Linux and AWS Linux only. We generally use the AWS Linux environment, have not used Ubuntu for a while, believe it should still work. It does use bash scripts, other than that it doesn't really depend that much on the development environment. What's critical is that the Go compiler that's used is Go version 1.13.14. If it does not match exactly, then when at runtime, the plugins will fail to load because they will not match with the class manager infrastructure. This is a limitation of the Go compiler and runtime environment. Let's go verify that, shall we? So let me do a clear. So first, this is the environment we're running on. Second, let's go look at the Go version. You notice it's Go 1.13.14 Linux AMD. And that matches exactly. Other prerequisites, you must have Docker installed, and it must be using the standard environment because it's going to pull down some public images that we put up in the hub.docker.com. These are specifically a rebuild of the peer and the node images, the peer and the orderer. The reason why is because the default builds that are currently downloaded do not support dynamically loading of shared objects at runtime, and the Go plugins are shared objects which contain the classes, so it's necessary to put that in. So we rebuilt it from the sources and added in the sources for Hyperledger Fabric that we're running on are version 2.2. We will upgrade over time, of course. And the only other minor change is we changed the core config to enable shared object loading and a couple other switches in there. We did not change the sources whatsoever. Also, as listed, Git must be installed because we do Git clone. This is a Git environment. And curl is installed because that's what we use to load the bootstrap and set up the environment. Once that's set up, you have to do the following steps, and then we'll go through it. So the next step is that you must have the directory home/Prasaga. That's the root home/Prasaga. It has to be root, /home/Prasaga. Again, this is a limitation of the Go environment. The interface to the class manager infrastructure requires that your code imports two packages. Both of them are built in the home/Prasaga/Xbom/HLFXBOM directory tree. We'll show you how that works. And so your Go path must have that environment in it, that environment path in its set. So let's go make sure that we're in that directory. You'll notice that we are. And the directory is empty. So we're in home/Prasaga. And now we're going to run the download and setup. Just straight cut and paste. Go. you'll notice the hour appear in hour order are installed now. And the Docker, so Docker images shows that. Just do that again. There you go. In the directory, you'll notice that we have fabric samples, and this is actually the fabric samples for 2.2 overlaid with a couple of minor changes to make it run the way we show in other videos with the test network, and that I'll run real quickly at the end of this. Also installs the Xbom tree, and you'll notice the original Xbom bootstrap is right here that we just ran. So if anybody wants to look through it, you can see it. Let me do that again this way. And you'll notice that it does the Docker pulls. And we do a little bit of setup. We do a checkout down here. Here's the git checkout. Here's a git clone. And a little bit of setup to set up the environment. I will say that this is not a heavily error-checked script. So if you see any errors or things do not run exactly, if it doesn't look like the end result we set up here, may have to walk through the script and look for any errors that you get with it. And then you might want to actually rerun this script if you can also download the script separately and run it with a bash-x or something like that. And a little bit into just take a quick look into the directory, because this is what's is sitting in the source tree. And here's some example sources. There's the samples. I'll go into in another video the internals of what a class looks like and what stub files mean and that type of thing. Right now we're just doing a quick example build of this. Let's go back to the README for a minute. So the README walks through what the rest of the steps do, explains what these pieces are, walks all the way through it and tells you all the pieces that are here. And then we do the build of the sources because we need to build them to actual plugins, just like you would build your own classes. We've already set up a script to do that, and it's called make.tgz. And what it's doing is the way that you do an external build in Hyperledger Fabric uses a tarzip file for your chain code. In our case, we actually include the chain code and the classes in it for the development environment so that they can be dynamically loaded. And this is literally what the run of that looks like. And we're going to go run that live right now. And we're going to test it. So we go into, again, we go into here, we go into Fabric Samples, go to chain code, go to Class Manager. Here's the tree. Let's eliminate these guys so you can see them being rebuilt. Look at the make file before we run it, the make script rather. And you'll see it's a very short script. Again, notice the must-have home Prasaga. And then it's going to run through it. I'll pop down to the main directory, but there's nothing to build in there. And then it'll go over to the classes directory and build those. Then it's going to do a couple of commands that are specific to setting this up for Hyperledger Fabric external build load. You will now notice that we have, in fact, a newly built class manager TGZ that contains both the chain code and the dynamically loaded classes. The way we're doing this right now is we're putting everything together. At a later time, you can easily set up a Docker path to any sort of local directory. Right now, we do not support remote download of classes, say across HTTP download. That's coming in the future. This is a test network at the moment, so that part's not necessary. Okay. Let's pop up to the test network directory, and this has been overlaid with our setup as been shown in other videos. One of the key differences is that the Docker compose file for the test network has been slightly modified from the original. The main difference you'll see here is that we've added in the class manager scripts and access so that this is where the external build scripts are for running a external class, an external chain code. The class manager infrastructure is external chain code. The classes load on top of it. That's from another video. Okay. Also, in the scripts directory, I've left a handful of useful scripts to cut and paste. And I'm actually going to open one of these in a window so I can cut and paste this in right now so we can execute it. We'll bring up a little editor. And it's actually already set up. Now, one of the tricks is that the way this is set up is that the root nonce for creating the ledger object IDs, which are a secure hash chain, is actually hard-coded, so that it always starts with the same value. So these are not, so that the ledger object IDs are not random. In a full system, you would want to actually use a random seed each time you start it. But for development purposes, you don't want that because then you can't do things like just cut and paste things in the way of doing it. And let's go. This will come up. Takes a little bit to start. There's the Docker images being loaded, the orderer, 2 peers. It's a very simple test network. Apparently I have to unmute myself. That was a little surprise. This just takes a couple minutes to run. Basically validation that everything loads and runs correctly and that the build worked. chain code is being installed. Previous video walks through some of this and what the pieces are in the individual scripts. And it's going to initialize it. Here's your init. And sorry, that was the commit. The init is still coming. There's the init. Then the bootstrap init loads the initial classes. Notice all objects saved. Doing a couple of gets that you can also see from previous videos. Create a new object, last factory, new count. And now we're just going to do the last piece, which is demonstrate. We can send a message to that as well. And this is going to do the inspect call right here. It's a little annoying. How do we get to it? Nope. Come on. I can get you. There we go. This just returns back the JSON schema as we've shown in other videos. And basically we are done now. Let's pop back up. So again, what we've shown, we're running the test network. We're loading classes. We load the chain code, load classes, can send, create objects, send messages to them. System's up and running. You would then be able to develop your own classes. And although they are currently in the directory classes, you are free to put them anywhere you like, with a couple of caveats that you must set up the Go path correctly to import the interface files for the class manager infrastructure. And that's it. There's not much more to it. Setup's pretty straightforward. Thank you very much for watching. For more information about Prasaga, about the extensible blockchain object model running on Hyperledger Fabric, and our future data grid blockchain technology, please visit us at prasaga.com. Thank you.